All right, well, welcome America, welcome Justin Bieber. Thank you for watching. Thank you for coming out today. We have a great show for you. Today we are going to be doing 2 problems from the worksheet that I will attach. So we're going to find the complex zeros of each polynomial function, and then we are going to write it in factored form. Now, yes, problem number 10, we're going to do 10 and 11. Problem number 10 can actually be factored from the start, but we're just going to pretend like we don't remember how to factor since we pretty much didn't have Algebra 2 last year, and go from there. So we are going to bring in some things that we learned last time. So last time we were learning about finding all the real zeros. We're going to approach this problem the exact same way as we would those problems. So we're going to go ahead and look at this and say, all right, where do we start? We weren't given any zeros to divide in. We have to find them. So it'd probably be easiest to figure out all the possible zeros first, and then decide or look to see if there are any positive or negative ones, how many there are, and go from there. So P over Q, that's just 1 over 1. So if I were to figure out all the possible zeros, it's just going to be plus or minus 1. That's it. So how do I know which one to start with? Well, I know that I have one positive 0, because when I look at the signs for f of x, I go from positive to negative, which tells us that we have one positive 0. And since we only have options of 1 and negative 1, we're going to start with 1. So we're going to divide 1 in, and we know it goes in because we don't have many options. And we can use synthetic because that is in the form, we know what the 0 is, it's 1. So the factor would be x minus 1, the 0 is going to be 1. So now I'm going to write all the coefficients, and I'm going to start with x cubed. I'm going to put a placeholder for x squared and a placeholder for x. So I've got 1 x cubed, 0 x squareds, 0 x's, and negative 1. And then we divide. 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1, and that goes in evenly because the remainder is 0. So fire. I knew you guys were going to love this. Okay, so we have 3 zeros, and we know we had one positive 0, and we have, that means the leftover, the last 2 zeros have to be imaginary. Also, this 1 is the leading coefficient for x cubed, and we divided an x out. So this 1 is the leading coefficient for x squared. So I'm going to go ahead and write this as a trinomial. So this is x squared plus x plus 1. Now, if we were to go ahead and try to factor that, okay, we know it can't factor. But if we tried, this would be xx plus plus, and then these numbers would have to be 1s. And we are not going to get a 1x in the middle here. 1 times 1 is 1, but 1x times plus 1x is 2x, not 1x. So this doesn't factor. So we say, all right, we tried factoring. We always try factoring first. It doesn't work. When that happens, and this is from Algebra 1 and Algebra 2, we have to go straight to the quadratic formula. Yay! Okay, so a couple people rolled their eyes when I said that. Like I said, we go straight to the quadratic formula, and then I saw. Okay, so A is the leading coefficient of x squared. So that's A is 1, B is 1, and C is 1. They're all 1. So x equals, and you should just memorize this formula. Everyone should just remember it. Did you guys remember, were you guys asked to memorize this formula?
No, maybe. I don't remember.
When I taught middle school and we taught this, we used to use negative b plus or minus the square root b times b minus 4ac all over 2a. And then we'd sing it in rounds.
I did that in Algebra 1.
Should we do that?
We got extra credit. That's when extra credit was allowed.
Do you have reason over?
No, I hadn't stopped.
I think we should do that. And then we should sing it in rounds and send it to the chorus teacher. Okay.
Yeah, I did it in the class.
Negative b plus or minus
He yelled at us one time. It was so scary.
square root of b squared minus 4ac is just they're both 1s, all over 2, and then times a is 1. Now what's going to happen here, I'm running out of room. I'll just write it up here. We've got a negative under the radical. When that negative comes out, it's an I. So this is x equals -1 plus or minus I root 3 over 2. And that's usually how you write the zeros. Now, do we follow the directions? It says find all the complex zeros. So the zeros are, if you wanted to write all the zeros out, they would be x equals 1, and then -1 plus or minus I root 3 over 2, the entire thing over 2. And there are the zeros. How are we doing?
Not good.
Yeah, not lovely.
I mean, it's better than trig, right?
Yes, anything better than trig.
We're going to do one more problem, number 11. So got a little bit more going on. You're going to love it.
Oh yes. My trust issues are really.
Okay. Number 11. All right, so when we're trying to figure out the possible zeros, we have a few more options than 1 and -1. So that's plus or minus all the factors of 26 over plus or minus all the factors of 1. Well, that means I have to just write out the factors of 26, because if I put them over 1, they're all going to be the same. So what are the factors of 26? So P over Q equals plus or minus. So we've got 1, 2, what else? 13 and 26. Those are our options to divide. Now let's see. I don't want to have to really guess. It'd be easier to know if there are any positives or negatives. So let's go ahead and do that first. So if we look at f of x, we say, all right, how many sign changes are there? So positive zeros. This is f of x. We have from plus to minus, that's 1 sign. What is that? Is it equal sign? Help me. It's a plus. Okay. So from plus, that's a 1 sign change, 2 sign changes, 3 sign changes, which means we have 3 or 1 positive zeros. So I'm going to write 3, because they come in pairs, or 1 possible zeros. So if we go through, we find that we have 2 positive zeros. We know that there's a third one. For negative zeros, I'm not going to write all this out, because you can really see very easily, if I plug in negative x into x cubed, that sign's going to change, because negative x times negative x times negative x is negative x cubed. If I plug in negative x in here for x squared, those x's are going to cancel, because that degree's even. So that's just going to be a negative x times a negative x. Those will cancel. This sign's going to stay the same. This sign's going to change. It's an odd exponent. So this will be negative x cubed, negative 8x squared, negative 25x, and negative 26. No sign changes, which means we have no negative zeros. So we are not even going to try those negative numbers. Now we have a better idea where to start. I always like starting with 1. 1 doesn't go in, but I think we should start there anyway. So I want you to see what it looks like when you try a number and it doesn't work. So we're going to try 1. Leading coefficients. I can just stop. I'm not going to get 0 as a remainder. So that doesn't go in. Try something else. 2. Went in evenly. Perfect. Okay, so I'm going to write this as a trinomial. Try to factor it. This is a minus minus because we need these two numbers to multiply to get 13, and when we add, we have to get negative 6. We're not going to find anything because these two numbers have to be 13 and 1 because there are no other factors of 13. And negative 13 plus negative 1 is not going to give us negative 6, so it does not factor. We tried. We tried. Which means we only have one positive 0 and 2 imaginary zeros. Awesome. So now what do we have to do? It didn't factor. Where do we go? Quadratic formula. Boom. Okay, negative, I might run out of RAM here. I'll do it here. Negative b plus or minus the square root of b squared. Anytime b is negative and you're squaring it, it's going to be positive. B squared minus 4 times a, which is 1, times c, which is 13, all over 2a, and a is 1, so I'll just put a 2 there. That is going to be negative 16 when I add those together. So I've got negative 6 plus or minus the square root of negative 16 over 2. That negative 16 is going to come out of the radical, and it's going to be a 4i. Square root of 16 is 4. The negative 1 is an I. So I'll rewrite that as negative 6 plus or minus 4i over 2. We're almost done. Each of these terms can be divided by 2. So we need to simplify those. And I should just show you this. You don't usually break it up like this, but this is why. If I rewrote this like this, you can see the negative 6 and the 4 both have to be divided by 2. So I'm just going to go ahead and cancel. Two goes into 6. Negative 3, and then plus or minus 2i. That's it. So the zeros are at 1, 2, and negative 3 plus or minus 2i. And if I, oh, you're right, one didn't work. And that also makes sense because the original polynomial is an x cubed, which means there are 3 zeros, and we have 1, 2, 3. Thank you, guys. To write this as a polynomial, it would look like this. F of x equals x minus 2, and then this unfactorable trinomial. Like that. Without the equal sign. That's it. Are we good? Questions? All right.